Armando has biology and medicine videos. Please make sure to subscribe. Join the 4-man group for the latest videos. Please visit Facebook Armando has In this video, we are going to look at the mechanisms of renin release. And there are three main ones. But before we go and look into the mechanisms of renin release, let's just understand where it comes from, which is the kidneys. So the kidneys actually produce the renin, and renin is an enzyme, an important enzyme that aims to increase blood pressure. So let's just try to understand the structure of the kidneys, like what it's made of. And it's made out of the functional units called the nephron. The nephron has a front, the Bowman's capsule area. It has the proximal convoluted tubules. It has the loop of Henle, which is essentially a loop, and then has a distal convoluted tubules, which actually goes back up and sort of meets with the head of the nephron, and then the collecting ducts, where urine essentially comes through, produced. So here I'm drawing a blood vessel. The blood vessel will enter the glomerulus, the Bowman's capsule area, and the blood will be filtered into the nephron, and then the remaining plasma will leave the blood vessel. And if you want to understand more about this nephron and the kidney physiology, please watch a video on that. But we won't really talk about that there. But we will focus on this section here, because this section is where we can find cells that produce renin. So let's just zoom into this section and understand a bit more about the structures and cells found in this area. So here, this area is known as the juxtaglomerular apparatus, and it essentially consists of the head of the nephron here. It has the Bowman's capsule, which is essentially this space within the head of the nephron, and then you have the proximal convoluted tubules, which are made up of more cuboidal-like cells, as you can see, whereas the head of the nephron, it's sort of just squamous cells, just thin cells. And as I mentioned before, the distal convoluted tubules of the nephron actually sort of meets back up with the head of the nephron. And this is important because there are cells around this area known as the macula densa cells. And we will talk about these cells soon enough. And again, just to orientate where we have blood vessels coming into the head of the nephron, blood vessel known as the afferent arteriole, and the afferent arteriole will bring blood into the Bowman's capsule to form the glomerulus, and then this blood, the plasma, will be filtrated into the nephron, and then the remaining plasma will just leave out through the efferent arteriole. Now, there are a group of cells located around here where the afferent arteriole comes in, around this area, and where the distal convoluted tubule sort of meets the head of the nephron. There are a group of cells here known as the juxtaglomerular cells. And it is these cells, the juxtaglomerular cells, that produce the enzyme renin. When renin is produced, renin does not get filtrated into the nephron, but it just passes through all these blood vessel stuff and will leave through the efferent arteriole. And then renin will just enter systemic circulation. So, there are three ways renin is released. First way is through what's known as the baroreceptor mechanism. The baroreceptors are a group of receptors that detect changes in pressure. So, when there is decreased pressure in the afferent arteriole, this will promote renin release. Okay, just before we continue on, why would this be? Well, the goal of renin is to increase blood pressure. So if you have a decrease in pressure, this tells the juxtaglomerular cells that, hang on, we have decrease in blood pressure. Let us make renin to increase blood pressure. So that is the first mechanism of how renin is released, through the baroreceptor mechanism. The second mechanism is simple. It's the sympathetic nerve mechanism. And this is essentially the sympathetic nerve fibers, which are beta 1 adrenergic nerves that stimulate renin release. Because during periods of sympathetic activity, fight or flight, you usually have an increase in blood pressure, and so you have renin release. The third mechanism, which is probably one of the most important, is the macula densa mechanism. And macula densas are sort of chemoreceptors that detect how much sodium chloride are passing through the distal convoluted tubules. And so if there's a decrease in sodium chloride in the distal convoluted tubules, these macula densa cells will stimulate the juxtaglomerular cells to produce renin. But it's also the same case if there's an increase in sodium chloride. If there's an increase in sodium chloride, this will tell the juxtaglomerular cells to stop producing renin. And similarly with the baroreceptor. Anyway, let's talk a bit more about renin and what it does, just briefly.